Welcome, welcome, welcome. Yeah, I'm super excited, and I think then I can use 3 times welcome. So
3 times.
3 times. It was always my dream. Do 3 times welcome. So yeah, we are here in the ICAR training facility here in Chicago. So we are in our ADAS lab, no EV lab. We don't talk about ADAS today. So I have with me 2 really, really great guests. Neil is not really a guest, he's an employee, but he is a specialist for electric vehicles. And yeah, that's why my excitement is so high. Chuck. Welcome, Chuck. Thank you for coming.
Thanks for having me.
So Chuck is with Redline Detection.
That's right.
And you guys are, I think, the leader when it comes to battery enclosure testing. And I know you work a lot with several manufacturers on that subject.
We do. Yeah, we work with a lot of different OEMs, different training industries, like yourself, different industry bodies like SAE and other areas like that. So yeah, we're pretty prolific.
So we have prepared here in our training facility the testing procedure. So we took our 2 batteries out of 2 vehicles, and we will do this. So Chuck will support us here and will guide us through this process and explain that. So high voltage battery enclosure and coolant testing. And that's the first question, of course, Chuck, why we have to do it, when we have to do it, or what is the consequence even when we're not doing it and missing this part of the repair procedure.
Yeah, so 2022 taught us a lot about the consequences, right? So if you even look in the news, we've seen stop sale orders on EVs due to water intrusion. We've seen, even an OEM in China had done a recall, something like 60,000 vehicles due to water intrusion risk. So there's certainly that aspect of it. The other side of that, of course, is for safety, for the life of the battery as well. We want to protect the battery, make sure that you don't have dust in the enclosure, make sure that you don't get water or water vapor into the enclosures, which can cause, certainly cause problems with electric batteries. So water in batteries equals bad, we will just say. And so up to and including, even catastrophic events. So we want to make sure that we seal these batteries.
So in Florida, we learned salt water is much, much worse than
yeah, that's even worse. Florida. It was really pretty eye-opening to see all the thousands of vehicles that are in these floodplains and spontaneously combusting, on flatbed trucks and in salvage yards and things like that. And we've seen some of that before, even last year or even prior to the hurricane. We've seen some of these, especially after a collision event, and then, water gets into an enclosure and a car goes up in flames. We've seen stuff like that. Luckily, it's sort of far between. In some cases, it's a little bit more prevalent. It really comes down to the type of battery that you have, the type of collision that you have, and also every OEM takes a different standpoint from an inspection standpoint, from a testing standpoint prior to putting them back into the vehicle, things like that. So it kind of ranges all over.
Yeah. No. To give them a little bit more perspective to it. And I think we have to see it also on the other side. And there's often a lot of people out there who say, oh, those EVs, they are dangerous and they go on fire. Yeah, fire on an electric vehicle is pretty impactful. Then it gets up to 5,000 degrees Fahrenheit. This is really, really hot. But on the other side, I know for a fact that there was 6,000 electric vehicles registered in the floodline in Tampa. So in where Hurricane Ian came in, 6,000 vehicles. We don't know how many really, really got impacted by it at the end, but I heard from registered, I think 27 fires. So let's say 50% were maybe impacted of the 6,000 cars, and then let's say 30 of them had a thermal runaway. It is pretty awesome. So that means how the manufacturer seals the battery, protects the owner, driver, etc. We are on a good way. Yeah. But of course, there's always the event of an accident, and that's the big question, and that's what I wanted to dive in today. When is it necessary to check and high voltage battery enclosure, when it's important to check the coolant line, what goes through the battery. So, and there is also much, much more. And Neil, we talk always about the high voltage battery or the high voltage vehicle intake process. So now the vehicle arrives at your lot on a flatbed. We have to take the car down, and then it stands there. So what do you do to protect yourself, your technicians, as a shop owner, for example? So what is the right step to go through? And I know this is your expertise, what you come in and always, go through.
Well, definitely, I would highly recommend the industry to do a post-scan, a pre-scan, and hook up your scanner and look at some live data, potentially with an OE scanner, that you can go inside that battery and look into the values of temperature and battery voltages. So we're talking about separate cells here, and we want to see those cells at a very equal level. So preferably no difference than 150 millivolts per cell. The computer, the BMS is registering this, but you can do that as a technician yourself as well. So if you would have a case of that, you could have warm spots in your high voltage battery as well, and current flowing going from one dead battery to a good live battery and sharing that current. And now we got current flowing inside the battery itself, which could generate a future terminal event. So that is a must once a vehicle comes in on a flatbed after a collision. Reason being is that if a car gets into an accident, a lot of G-forces are implemented on the high voltage battery. Now, I'm going to ask you, did you hit your head once or twice hard in your lifetime?
Don't ask.
Knowing you, I'm absolutely sure I can confirm that answer to a yes, right? I know you played ice hockey, so once you get a big bang on your head, let's say it like that, your brain could get upset and could swell and hit in your inside of your skull. We call it a concussion. Now all of a sudden your eyesight, your hearing, your stability, you could get nauseous. Multiple symptoms could originate from that concussion. So, and that's what we have in a high voltage battery, potentially as well after a collision, that we could have a concussion inside one of our cells or multiple cells.
So you were saying G-force. So those G-forces get absorbed by the chassis. Now, Chuck, we know the battery is part of the chassis. It's mounted to the frame, etc. We'll see that on the battery in a few minutes. So now, the potential of this absorbing the energy could cause micro cracks or others in the battery. So what is your experience there? How often you see this? Or
Yeah, so it's a really difficult question to answer. And I think where we are as an industry is we're trying to figure out what's going on, right? So we see some evidence that, and I think we've all seen it at this point, evidence that, after a collision, events can happen to the battery. It's difficult, you have a battery, there's a lid on it, you can't really see what's going on inside of the battery. If you look at the battery that we're going to be testing on today, there's modules inside the battery, and there's clips holding those modules on either side, right? Little metal clips. Those are made to hold the module inside of the battery pack so they don't move around, but they're not necessarily made to take a front end full force impact collision, where you just stop completely like that. And we don't know, how much acceleration is too much acceleration. And I would imagine, this differs from battery design to battery design, right? All these batteries, they're built differently. If you look at a Mach-E battery behind us versus say, like a Volkswagen ID4 battery, completely different constructions internally, completely different batteries. So, it sort of remains to be seen. And the other problem, not problem, but it's a good thing that's happening, is that, we're seeing generational design improvements as we go, and as you would expect, right? So as we, gather more and more information, that allows the OEM to make better improvements and make safer batteries and more sealed enclosures, better enclosures. With technology and the investment that's going on in the industry right now, I think that's we're going to see that continue and maybe accelerate.
Awesome. So Chuck, of course, for me, the question of the day, can you go over to Joel, to the battery, and make your magic happen and show us how that really works and what is the procedure for technicians in the future? And I think that's what you have to learn and have to see what's happening in the future.
Yeah, so yeah, I'm excited to do that.
You move on, go over.
Okay.
We give you a minute.
Okay,
Over there.
sounds good.
And watch out for watch out for Joel. So Joel is at the battery, so they have everything prepared. What we need to perform this test. So Joel, the question of the day, and I give it over to you. Do we have to perform this enclosure testing when you run over an alligator? So that's the question of the day. Over to Joel. Thank you. Go into the screen and
A road alligator.
Thank you, guys. Yeah, so as Dirk said, the old road alligator here, that comes courtesy of our buddies from the J&J show, Jeff Buckley and John Firm. But road alligators would be a big tire retread sitting on the ground. So if you go over and hit that tire retread, this battery is the whole length of the underside of the vehicle. You could cause some damage, and Ford does have a test procedure to tell you if the dents underneath the battery are too big or too small, if they're okay. So you follow proper procedure, and you might have to do enclosure testing afterwards, depending on how hard that vehicle is hit. So what we have here, we have a battery of our 21 Mustang Mach-E. We have gone through the power down procedure. We have verified zero potential, so this battery is safe. We also have a battery over here from a Spark EV. Both batteries have been depowered, checked for zero potential, so we're safe to work on them and we're not going to get ourselves hurt. So Chuck is here to kind of show us how do we do this battery enclosure testing. And one of the first things that we need with our battery enclosure testing is some special adapters, right?
Correct. Yeah. So, and you can find these at Ford dealers today, but they're basically the same connectors, but they're potted with the silicone to be able to seal that sealing surface. And that's important that we use, I would say, part of the reason other than the obvious that these fit right on is that, you're also connecting the same way you would connect the actual power connectors. So it's a great way to see if you've got a problem with the sealing surface or anything like that. So later we can check for leaks on that, but right now we're going to test for that.
These connectors from the factory are like a weather pack type connection where there's a seal on the inside of the connection, and there's actually some breathability between the inside of the battery and the connector itself is sealed off on the vehicle. So that's how we're allowed to inject smoke inside the system here, is we're actually going through these connections. So
so we're not going to inject smoke.
So
no visual vapor today. These are air-only tests for Ford. That's part of the OEM service procedures. That's something that you definitely want to do, is make sure that you follow the OEM service procedures, and you also reference those OEM service procedures prior to doing any kind of work on the battery, right? Because they can change.
My brain was stuck. The Spark battery over here actually uses smoke.
Yes.
The Mustang one, which we've been working on for a couple of days now, uses air. But so we have it all kind of set up here. So if we kind of look, if we can zoom in kind of on the battery connections up in the front here, we can kind of take a look at a couple of connections here. We have our two coolant connections. We have a coolant outlet, coolant inlet. This is to cool the battery modules.
Correct.
We have our heater and AC lines out here. Right. We have our DC fast charge port connection here. We have our front inverter, and then we have our low voltage for the BMS, stuff like that. Correct. And actually, if you look, the low voltage connection here doesn't have a connector on it, because if you actually look inside, it's sealed off with epoxy from the factory. So this connection here doesn't actually have anything coming out of it.
Right.
And then on the back side of the battery, there's also a connection on there as well for the rear drive unit, because this is an all-wheel drive vehicle.
Correct. Yep. And when we go to check for leaks on this battery, we'll be showing that as well. So yeah, we're going to go in right through this connector. This is actually a common way to do testing. We see this often, where you're going through these connectors. They breathe a little bit, and this allows the pressure to enter into the battery enclosure. So in this test, there's some major tests that OEMs do. What I see probably most often is not a test like this. This is a flow test. I think what we see probably most often is a pressure decay test. I would say the second most often would be a vacuum rise test. So these are tests where you pump to a certain enclosure pressure, you let that pressure stabilize, and then you watch the decay over time. And from there, you can understand what the leak rate of that battery is. And there's a specification you need to meet of whether that battery meets that leak rate specification or not. So that's a pass or fail. In a test like this is really a flow test. And today we're going to be using this dual machine over here to be able to do the test. You can find this in the Rotunda program for Ford. This is approved equipment for them. On the left side, we're going to ignore that today. This is turbocharging, exhaust testing, high flow, way too much pressure for a battery. Awesome for warranty and for things like that, and really helps technicians, but this is where we want to focus today. So this half of the machine is an evap machine. For evap pressure or evaporative emissions testing, you can use that, of course, you can use that in the visual vapor that this produces to be able to pinpoint leaks. But today we're just going to be doing an air-only test, and that's part of the service procedure. So we're going to have air-only. This is pressure regulated to a half a PSI, or about 35 millibar. I think that's about right, 35 millibar test. And so we have a pressure gauge, and then we have a flow meter on here. And the flow meter has a little ball that floats up to the top. And so when we start this test, and I think looks like this battery's...
because this test takes a little bit of time to pressurize the vessel and everything, I started while you guys were talking earlier, so that's we can cut down on some of the extra time. So
extra time.
It started all the way up here at the top, and then as we started to flow more air in, it started dropping. So right now we're just about halfway, 0.5 on here. So once this touches down on the bottom, what does that mean?
Yeah, so that's the pass-fail criteria for Ford's test on this Mach-E battery. You monitor this flow meter until the ball goes to the bottom of the gauge. If the ball does go to the bottom of the gauge, you pass the test. And if the ball doesn't drop all over the gauge, or if it floats, then you have a leak in the battery, a gross leak. So these are gross leak tests. Every OEM has a little bit different test. This is in particular, more of a gross leak check, which is a check for things like, do you have the connectors
and one thing we didn't mention, I'm going to walk around the
plugged
back
in
of the battery here. If we can kind of zoom in on that vent patch we were talking about earlier.
Yeah.
There's actually a vent patch on top of the battery here, right here, where it allows it to breathe a little bit, right, Chuck?
Correct.
So we have to do something. So in Ford service procedure, they tell you to take and go ahead and put a Band-Aid over the top of the vent patch so we don't destroy it.
Right.
Then we're going to go ahead and we're going to put tape over the top of that to seal it off. And that way this vessel is now sealed. So,
exactly.
And this is an extended range battery from Ford. If this was a standard range battery, it'd actually be a flat top. So there's extra modules up here to make the extended range. Correct. So the vent patch would vary in location depending on which one it is, and also time to fill. This battery takes almost, from our experience, about 15 minutes or so to fill this and actually pressure test this. Yeah. Where a standard range battery might take a little bit less time.
Yeah, and it's an important aspect of that too, is that, with these machines, I think pretty much all of them on the market here, they have a 10-minute timer on them, and this test can take longer than 10 minutes in some cases. So if you need to restart the test, that's okay. You can just hit that button, you get another 10 minutes. But I think what we've been finding is for this particular battery, we're good to go. So it's pretty well sealed up.
So we can see here our ball now has dropped down to the bottom here. So we know that the flow test, it tests okay, right?
Yeah, that's right. So when you start the test, the flow is going to be up here, right? Because you're going to be pressurizing the enclosure, adding a lot of flow to the enclosure. And so what you're looking for in this kind of test is if you have, you want to make sure that the ball drops down so that the flow out of the battery doesn't exceed, what you would see as a 0 on this gauge. And so that's how you pass-fail this. So you just basically let it run. And if that floats down to the bottom after, say, 10, 15 minutes, you're good to go, and you pass the leak test.
That's Ford's OE test for this.
This is Ford's test.
For this specific battery. So
exactly.
You need to look at whatever your manufacturer is going to recommend. But
exactly.
Ford here, they want you to have it drop down to the bottom. That's a pass on this battery.
Exactly right. Yep. So this is the approved way to do it. This is the OEM method and test.
So I'm going to go ahead. I'm going to turn that off, and actually I'm going to take and unplug this real quick.
Okay.
Maybe they can pick up on my mic. You can kind of hear that depleting out, and actually. One of the cool things we noticed when we started doing this test is this cover, because it's a composite cover, it actually swells up a little bit like a balloon as you start to fill this enclosure. And then as we let the pressure out, it drops back down.
Yeah, exactly. So this cover is really just that. It's a cover. It's an SMC kind of cover. All these batteries are constructed differently, and some use metal covers and some bolt in the middle, and they don't really expand that much. They all kind of expand a little bit, but this one is a little bit more of a balloon. This is so it's a very large cover. It's all single piece. So one of the advantages of that is you don't have to worry about leaks in this top of the cover.
Yeah,
There's
that's
just
good.
no leaks. And
I think Dirk's got a quick question for us.
sure. Yeah.
We have already questions from the audience, so that's really, really cool. Thank you so much. When you guys have more questions, type them in. We are here to answer all your questions. So, question number one: do we have to remove this battery? So I see the batteries on the battery lift table. Joel, you removed the battery, but would be this procedure also possible when it would be still in the car? And maybe other manufacturers, there is it possible? So we have here the example as with the Ford vehicle. So what's going on? Do we have to remove it? Yes or no?
Yeah,
So that's going to be a loaded question. It depends on the manufacturer. So Chuck and I were discussing this yesterday as we were doing some testing, and he's obviously connected with some OEMs and knows a little bit more about the stuff. But for the Ford, the Mach-E, in order to do this test, you have to cover that vent patch, which is up underneath the rear seat area. So you have to drop the battery in this to do this test. Now, Chuck can explain some of these other manufacturers do have some tests where you can do them in the car, right?
Yeah, so we've seen, we have different tests that we've developed for BCLD that, you can do them in the vehicle. And so it really depends on the manufacturer and who's, running the tests. We like to see that because, I think especially in places like Europe, inspection maintenance is going to turn into a thing for battery testing. And so, you just have different tests. So if you have, I'll give you an example without naming an OEM, right? So in one OEM, they have two different kinds of tests that we're developing. One that's out of the vehicle and one that's in the vehicle. And the difference is that when it's out of the vehicle and you do the pressure enclosure test, you tape what we call umbrella valves or safety valves closed, so we can have a little higher pressure. You get a little better resolution on your test.
And that's just a different valve. Like we had a vent patch on.
Exactly. These vent patches, you have to put tape over them, right? And so there's a blow off pressure, right? So let's just make something up, 27 millibar, right? Okay, might be the blow off pressure. So in those cases, we would do a 20 millibar test where, before those vents open, and then you could do a leak down on this. On this particular battery, it's not possible to do, right? You have to be able to access that vent patch, just like that GM battery over there.
So it's all dependent. We got to read the OEM service info and find out. So I know, Neil, do you have something else for us, Neil?
Well, we have another question coming in. So, question, how long should this test actually take?
All right, that's another great question. So once again, it's all going to depend on how the OEM does it and how the tools work. So for example, this one here, we've seen about that 10-minute range, 15-minute range, depending on how long it's taken. That's for this test to fill this enclosure with a half a PSI.
Yeah, because the enclosure expands and that type of thing. And so with a flow test like this, and this particular battery, it's a large battery. I think yesterday when we were testing it over and over, I think it was about 10 minutes is about what it took. So
seems a lot longer than it actually is.
Yeah, it was just under 10 minutes, I think, and we had our results. So that's about how long this particular test would take. But if you talk about in general, it really ranges all over the place. And
because it's really going to depend on the size of the battery enclosure itself, and how much space internal volume there is.
The type of the battery, what the specification is, how it's designed, what the OEM decides of what needs to do. Some batteries take more stabilization time, right? So you get this little hysteresis that goes on. So you need a little bit longer stabilization. Other batteries, you can do a shorter stabilization, a shorter test on the pressure drop, or the vacuum rise, whatever test that you're using. So it varies all over the place. So if I, to come up with an average number, it's somewhere in the 5 to 10 minute range if we're following service procedures, right?
But once again, we always just check whatever the OEM procedure is. That's how we kind of follow that. So, Dirk, I know you got something else here.
Yeah, I have a couple of, I have thousands of questions, but really, for me, really important, and Chuck, maybe you can help us understanding here. So this test you perform is you put pressure into the battery enclosure. So let's see it from a different angle. You have a flooded vehicle coming to your lot, and, now is the question, did water go into the battery? So how you would test for this, then this is the opposite procedure. Water goes in, and with your pressure test, you can check if there is a battery leak in the enclosure. But what is with the vent? The vent is made that the battery vents out. And you explained a little bit of the vent already, the ventilation system of the battery. But the question is how we can now check the opposite way. Did water come in? How you check this vent? What we have to do? How shops dealing with this? How they make really sure there is no water in and the vehicle is safe, the battery is okay.
Yeah, so that's a great question. So let me answer it a couple different ways. First is, whatever the test procedure, and I'm going to go back to this, and I'm going to keep going back to this, but whatever the OEM tells you the test procedure is, that's a great way to start. Okay, and now let me kind of expand on that. So there are pressure tests, and then there are vacuum tests. In a vacuum test, it's a little bit more like real world in the aspect that you're looking for vapor getting inside of the battery, right? And so you're creating a flow path in towards the center of the battery rather than out of the battery. So you could argue that that's it's a great test to be able to determine if you're getting an inflow risk into your battery. So that's probably the best test. How do you know if there's water inside of the battery, sitting inside of the battery? Yeah.
That's one of those things that's hard to tell until you pull the battery and look inside it.
Yeah, that's basically all you can do.
The vent patch on this is like a Gore-Tex type material, so it's meant to resist water going in but still be breathable.
Right.
But at a certain point, depending on how high that water is, the pressure could push through that and cause an issue.
There's no guarantee, right? If you have an IP67 enclosure that you're testing to an approximate standard like that, which means the 6 in that means no dust intrusion, and the 7 in that means that the battery's sealed to up to a meter. That you can put the battery underwater for a meter up to 30 minutes and you don't have an ingress of moisture leak into the battery. But that's not these are not waterproof, right?
That's in a perfect environment. That's not, 100,000 miles in this car. It's been in an accident and, things can be tweaked and stuff. So
yeah,
it's right now we're still kind of learning all the stuff with this stuff. It's all new to us and we're trying to figure these things out as well to help inform the community so they know.
Yeah.
Do you have another question?
Oh man,
we still got a lot of stuff to do back here too.
I know. You have to get moving and working. So you talk, you don't work, guys. But hey, can you show the battery cells, Joel? Somebody's asked. He wants to see battery cells. Come on, open the lid of it.
Not today.
No, not today. But this
today.
is kind of a fascinating battery in that you can do a lid-off repair on this battery. Mm-hmm. And we'll talk about that a little bit more when we get into the coolant.
Dirk, how about we do this? We're going to start the coolant test here, and while this pressurizes, then we can go back to you and get some questions done. Yeah. So we have Chuck. Chuck's got the BCLD. It stands for what?
Battery coolant leak detector.
All right, so this is a lot of OEMs are using this tool now
to
not only pressure test the vessel, but also test a cooling system on it?
Many functions on this. It'll do low pressure vacuum tests. It'll do low pressure tests, overpressure tests. It'll inject a nano gas that we'll talk about a little bit later.
Favorite aspects of this.
Yeah, it's a cool
and then
thing.
My second favorite,
to look for leaks.
I'm going to steal your thunder a little bit. To do a coolant test, I need to drain the coolant out of the battery. So I pulled this battery out, and I got as much out as I could. I can't pick this thing up because it weighs 1,200 pounds and try and dump it out. So the BCLD actually has a cool function in it where it has a coolant purge function where we hooked up a long hose of the outlet into a container and hooked this up and it actually purged out all the rest of the liquid out of the system.
Yeah, right? Exactly. So we work in conjunction with OEM customers. We patented what we call a pulse purge function that allows you to, and it's tuned, but it allows you to pulse out more of the coolant out of the battery.
There's a lot of up, down, round, and round inside these batteries.
Right. So we took video of that. Maybe we can edit that in later or whatnot. But basically, even after blowing it out, I think you blew out some of the lines here with some low pressure. When we used that, we got even more coolant out of the battery.
So I tried to drain as much as I could with some compressed air, and then even when we hooked yours up, it still more came out, and we finally got to a point where it was pressurizing the way it should. So,
yeah, exactly.
So here we're going to do kind of like a cooling system pressure test for those of you that were used to working on ice engines, how we check our cooling system, except now we have a very fancy kind of test like this. So Ford wants you to hook up a regular old pump tester and pump it up, and like how we test a cooling system, look for pressure drop after a few minutes.
Yeah, exactly. So, in the Ford's test, so if you look in the source procedures, there's, you have a gauge set, you have a hand pump, right? And so you pump that up, I don't know, 80, 100 times, I don't know exactly, but however many times it takes.
To get to 25 PSI. So.
Right, to get to 25 PSI. And then you lock out the pressure, and then you look for a pressure, if you see any pressure drop that's visible. And, of course, you want to use the recommended equipment, because if you've got a bad gauge, it's really, or a less accurate gauge, or one that has too large of a range, you're not going to be able to resolve that, right? So you want to be able to see that kind of pressure drop.
Yeah, one of the cool things about this tool is you actually see a good resolution. You can see very good pressure drop, and we're not relying on just like a little needle gauge.
Right.
We're actually getting results in a graph too.
So this calibrates to atmospheric, so everything's a reference test, and that's exactly what we want to do from here.
So let's fire this thing up, and
Okay.
then we'll go back to Dirk. And
Yeah. So I'm going to
We'll
select
come back.
FEV-A here on the software. We usually put in a VIN number or a component part number, depending on which component we're testing, whether that be an inverter, motor, or whatever the case may be. So there's multiple types of tests.
How this system works. While Chuck's doing that, I'll kind of talk about that. So this is going to pressurize it. So this is a 25 PSI system. So we're going to pressure this 25 PSI. So it's about 30 seconds or so for it to build pressure inside here.
Yeah.
It's going to pressurize it. Then we go into a stabilization period, right? What happens in the stabilization period?
Get started. And then I'm going to walk over here to talk to you, because it's
Loud.
while this is running.
So actually, let's do this. Let's go back to Dirk, and then we'll come back to this once
Okay.
this is done making
Yeah.
noise.
Okay, yeah, no, a lot of really good points. One question what we got, and when should this test be considered to do? And this is a really, really good question, and possibly the question of the day, when you have to do it or when you should do it. And since we are in such an early state, every manufacturer has different requirements. So when I see in service information, some manufacturers say, hey, you have a scratch on the battery, what is longer than, 5 centimeters, you have to perform this test. So service information, position statements of manufacturer coming slowly more and more out, and then this is a really important subject. This is so important that we want to make sure that nothing happens. I got reporting out of Europe, and you guys know where I'm from. So I have friends, and they're telling me things. And the EV car population is there a little bit higher. Multiple times it got reported that vehicles got repaired, and 2-3 weeks after the repair, vehicle went on fire. And where is it coming from? Then over a slow or a longer time period, water, dust, moist or more moist intrusion came into the battery. Then nobody was checking this important part. And that's the reason why I said to Chuck, you have to come. You have to help us figuring out. And we wanted to, inform you guys about this really, really important subject. So it's the question of the day. And thank you for asking this. And thank you really for participating and looking into it. So Chuck, Joel, I heard the noise is gone. Are you guys ready for showing and explaining us the coolant leak test?
Yep.
Yeah, absolutely.
So this went through pressurized to 25 PSI. Now we're in the stabilization process where we're looking for how much time is the stabilization?
I put a 2-minute stabilization on this just to make sure that it's nice and stable before we do the test.
We pressurize it, and then we're going to wait for 2 minutes, and we'll wait for that pressure to stabilize in there, because there's all little nooks and crannies, maybe some bubbles that are going to pop and stuff, and we're going to create that stabilization.
Yeah, exactly. So there is no Ford test for this battery on this equipment. So this is more of a demonstration. We're simulating what a hand pump test would be. I'm adding a little bit to that to make sure that we get a good test here. I put a 2-minute test on the back end of that. If you look in the instruction, I think it's something like it could be 3 to 15 minutes or something like.
Minutes
So
I want to say, but
2 minutes with our resolution is more than enough to be able to determine if you have a leak or not.
So then after the stabilization period, then it goes into a check procedure, and after that set time, then it tells you basically pass or fail at that point.
Pass or fail based on a threshold that I came up with that it should be pretty close. Yeah, pretty close.
So this is a nice way to kind of get some good data. What can you do with the data?
Yeah, so with this data now, you can get a report. So every test that happens in this equipment is logged. So you get full logs. High resolution logs of everything that's going on during tests. Usually those logs are really used for engineering purposes more than anything. And then also we get a nice report that we can capture. And those reports, of course, can be sent to the cloud. They can be associated with VINs. Reports can be put on, a post-scan report, for example, be part of a collision workflow and just go, right where it needs to go electronically, and just like any other type of test. So
this is some good data to have.
Yeah, it's great data to have, and the data is kind of the name of the game today, right? So, that's pretty much everybody is focused on collecting data around these types of things. So, the more data, the better. And being able to determine what you can do with that data. And that's looking for, common problems, pattern problems. For an enclosure test, especially for the leak test, having, captured information allows, in some cases allows improvements to the battery designs even, right? If you have a problem area on a battery, you can kind of add that to your next iteration of design or whatnot. So there's a lot of advantages.
Neil's got something for us real quick here.
Thank you, Joel. So I got a great question in here, and they are asking, is it possible that the enclosure could be damaged, but the battery is good? And then the follow-up on that question, and then replace the enclosure, but keeping the battery. We talked about that.
I was actually just rummaging through Ford's service info the other day and came across a TSB that came out from them. Prior to this TSB, if the battery case is damaged for Ford, you had to replace the whole battery. Now they've gave criteria that if it's within X amount of damage, you can actually take and order new housing and swap everything from the old battery into the new housing, which saves a significant amount of money. But that's going to depend on every manufacturers have a different position on that stuff. So you'd have to kind of read through your procedures and see what they.
Yeah, this is in particular, this battery is fairly serviceable, right? So there's 64 bolts we talked about earlier that hold this lid on. You can take this off and you can get in here. If you look on the inside here, these go in through this kind of like a little attachment manifold here. There's attachments, hose attachments on the underside. The hoses run through here, and then each one of the battery modules has a cooling plate that's all plumbed in. And so you can actually get to things to repair that inside of this battery.
A pretty component level replacement on this battery itself. So that's your mileage will vary. Also, I want to point out, we had kind of tight shop, but there's two coolant tubes up above the top here. These actually go to the rear drive unit, so these are separate from the inside battery loop right now. So
exactly. So
we went through, we passed this test.
We passed that test, so we're good there. If we did find a leak, we could always inject a high pressure nano in there, and then we can go signal for the leak.
All right, so Dirk, you got a question over there for us?
I have one thing. Joel, as you remember, I made you taking out the spark battery for this episode. Yes. So, I don't want it to make you work, and then it's not getting pointed out in this show. So the reason why I asked Joel taking the spark battery out is we have two disconnecting procedures from a technology standpoint on this vehicle. So the spark has a battery disconnect. So a high voltage battery disconnect, and the Ford Mach-E works with a service disconnect. And this is an important part when it comes to the battery enclosure testing. So Joel, can you dive in there and can you point out and explain what is the difference and why is it a big point for this test?
Yeah, as you were talking there, I was getting prepped. I checked my gloves to make sure that they're good because we're going to have to plug in this high voltage disconnect. And this high voltage disconnect, what it does is it effectively splits the battery into two sections. So it's going to take the battery voltage and cut it in half, so we have two separate sides. In order to do this testing, we have to put this service disconnect plug back in so it seals this top off. So I'm going to go ahead and I'm going to put this back in. And now just to verify, I'm going to come back over here to my main plug, and I'm going to do a zero potential check really quick. I'm going to pull this plug off. I'm going to grab my 2-pole tester. If I can get this plug off. There we go. I'm going to grab my 2-pole tester. I'm going to test it on the battery here, my 12-volt battery to know if it's good. All right. And I'm going to check, make sure my contactors are closed. Make sure my contactors are open and they're not closed. I'm going to go ahead and check high voltage positive, high voltage negative to ground, high voltage positive to ground. I have nothing there, so I have zero potential measured here. So it's safe for us to continue working on this battery.
So the big point here is that you have to put your high voltage disconnect back in to seal the battery. And there you can see in those connectors there is a seal what really seals the battery. So and Chuck, that's for you. In this point, the sealing, the leak, what could happen in the enclosure could be happening from a high voltage disconnect block, for example. Is this right?
Right. It happens all the time. As a matter of fact, on that battery, when I was here at iCar last time, we were testing that battery with nanogas, And that we got a signal from that, and we're like, how are we getting a signal for that? No, we didn't. It wasn't latched on all the way.
Those GM plugs, if you get them just the right way, they can seem like they're latched, but they're not fully latched.
Exactly.
So we're getting a little bit of leak. So that's where the nanogas technology from you guys comes into play. So we have some kind of cool tools here. If you've ever done any kind of AC work or something like that with a sniffer, they have a sniffer here, and then they have their nanogas, which we're injecting it into the enclosure right now, and that'll be a way for us to detect leaks on this. So
yeah, exactly. So
what I'm gonna do first, I'm gonna come ahead here, and we wanna make sure our tool works. So I'm gonna take and just crack open this a little bit, and we should be getting, all right, it's getting a leak, so I'm gonna pull this away, let it calm down, bring it back over here and check so we're not getting any leaks. So I'm gonna check my main connection here first, and then I'm gonna come over here and check my first connection here to make sure it's all going through. And then we wanna make sure what, Chuck?
yeah, so what we're doing, so how this works is that we generate our own trace gas that's inside of this unit, and it's our nano leak technology is patented. And we actually developed this for air brake systems to check leaks in that, and that was a high pressure situation. And it prevented, soapy water and that kind of spray thing from getting in your eyes when you're working under the truck. And it works great for these batteries too. It's clean, there's no residue. Unlike using like a vapor.
For leaks, I don't want to really be spraying soapy water.
Exactly. So what we're using is a half a PSI, which is what this enclosure is rating for. We're injecting the nano gas, and so we want to make sure that it's homogeneous inside, right? It proliferates all the way to the back of the battery, and so there's a connector back there. Joel's gonna, I think we can switch the camera angle to that. Joel's gonna go to
the back camera here.
Yeah, test to make sure that that you're getting gas all. Yep.
And we're getting gas coming out here. I can feel a little bit of flow coming out back here. And once again, this battery shut down. We verified zero potential beforehand, so it's okay for me to open that up. And then afterwards, I'm gonna go back and check here again. So since we have the camera back here again, I'll just kind of show one more time. We pull this off. And as soon as I pull that off, you can start hearing this thing beeping, going crazy. So we have gas going all the way through the battery. So now we're gonna go ahead and we're gonna do our enclosure test, right? So I can start, since we're at the same camera back here, I'm gonna start, just go along the edge here. How fast do we need to go when doing this, Chuck?
Yeah, so not too fast, nice and slow and methodical, right? It's almost, I don't know how to describe it. It's like, go around.
Too slow.
Yeah. If you've got a big leak, you can go pretty fast and you can signal. So how we usually do this is that we'll put this on the highest sensitivity and we look for the gross leak spots, right? And that's the first thing. So that way you can do a quick check all the way around the battery to see if you can find where that leak is. And if you find the location of the leak, then you can turn the sensitivity down on the detector. And this detector is tuned to this gas, so it's tuned specifically for this gas. So you go around and you turn the sensitivity down, and in that way you can now pinpoint the leak. And I can actually, in a lot of cases, I can tell you, even which direction the leak is coming out of the battery. And
so especially in a battery like this has 64 bolts holding its cover on. One loose bolt could run into an issue.
Exactly. So the normal leak test for this is a soapy water test, or a snoop test is another way to do that. So that you're spraying soapy water all over the battery. We like this method. A lot of OEMs use this method now. And are moving kind of into a different direction to do it this way. It's a lot cleaner. It's a super small molecule size, so it gets out even the smallest holes. And as you know from anything else, small leaks can turn into larger leaks. So we can catch problems before they get worse. So, but yeah, that's basically. So the process here would be to start around the major areas of. Especially if you've already done a repair on the battery, that area that you repaired is the first place that you would check, obviously. And then after that, we're checking around the connections, checking around this lid. If you have, especially with a battery like this, where you have a seal, that replaceable seal, which is kind of nice, but it's a smaller seal, much smaller than
like a typical engine gasket.
Like a gasket. So if you have a loose bolt here, and I've seen that happen where that'll signal.
Yeah, this definitely takes a lot of the guesswork out of the system, makes it a lot easier to do with all this type of stuff.
And you can reach places you can't usually reach.
So Dirk, I know you got something here.
So we are really far with the time. So you guys did awesome. Can I invite you guys here over to the desk? Come on, we finaling it out here. We have a few questions. I know Neil has a question in his mind. So guys, that was awesome. Come on, Joel, join us. Come squeeze in. squeeze in. So Neil, what was the
It's
question?
not a question. It was a little add-on here on going inside a high voltage battery. So that's called under life conditions, working under life conditions. And I want to give you a heads up to get the right information and the right education before you go inside a battery to repair a casing, a seal, or even fix battery cells, because some manufacturers, what I'm seeing or what we're hearing in Europe right now, are mentioning, hey, if you have a bad cell, you can go inside and change modules and components inside as well from the voltage side. So not just the casing. So, but education and information, priority before you as a technician and an industry professional go in there.
Thank you. That's absolutely the case. So, last question, what I see on the screen. So is there a way to use an infrared heat gauge to do a pre-check on the battery while it's still installed to gather information on the condition of the pack before we start working on the vehicle? So that's a long question. So I want to take this directly then. I work with different organizations and I learn a lot of that. So we always in our training class said, hey, take an infrared cam, go under the car and scan the vehicle if there's any heat pockets in there. So unfortunately, we didn't show that well, but that Ford Mach-E battery, what we have there, that casing, that lower casing, that metal what is used is so thick and strong that the reality is what we learned is you go with an infrared camera in there, you will not see a heat pocket. We always were under this impression then the heat rises, it's way too late that you really see this. So I don't want to encourage you not doing it. Then it has a huge advantage. So what you see is, and that's really cool, but on the other hand, also really scary. Then when we running into a thermal event, means the battery will go at some point into, or we creating a fire. The first thing what happens is that the battery will gas. So over the ventilation, the battery cell will react chemically and be producing fluoride gases. Those fluoride gases going out of the ventilation system. And you can see this gassing with the thermal, with a thermal image camera, not with a thermal temperature gauge. So we need an image. Then we can see that gas coming out. And then you know you are in trouble. So, and then it's a question, running or staying? No. Neil?
I would run.
You will run. Now, we're making fun about it, and I want to go get really serious back. Please take this test, do it. Every test what you do is gives you data, and data helps you to stay safe. So, but we learn where we're going, and this is, I think, the good way to finish this episode. What do you think? What is your last sentence, your last words? Where are we going with this testing?
Yeah.
How do you think, how impactful it will be for the collision industry in the future?
Well, I think it will be impactful. You know, if you look at the equipment that we have here, you know, it's already at the dealer level. This year, we're going to see that move into, you know, we've been working with collision since last year. So, you know, that'll come out this year for training and different training in collision. And then, you know, in shops probably towards the end of the year is my guess at the end of that. But so that, you know, we're definitely going to see that. And, you know, it's also upstream too, which is great because, you know, we're using this in manufacturing now in place of laboratory equipment. Matter of fact, that piece of equipment's from the VW battery lab. It's the type of equipment that we sell into the battery labs. So it's a great end-to-end chain. So as you develop tests and you're using the equipment, it's the same process, same thing. And then when technician gets it, they just, you know, you hook it up, push a button, and you get a pass-fail. We want to make this as easy as possible for the insurance industry or for the collision industry, so it works for everybody.
Another question came in, and it's also, are you guys involved in OEM testing when it comes, or investigation for potential water damage, especially when the vehicle was submerged in water? So do you guys are involved in this process, and do you guys learn? What do you guys do?
Yeah, we're not involved directly in those kind of things. So what we focus on is the equipment and providing the service to our OE customers, right? So we do a lot of consultation and that type of thing. It's more on the industry side and more on the SAEs of the world, right, where these discussions come up, and it's really discussions around safety and, what are the things that we need to do. And those are tough questions to answer, especially with all the changes that are happening. But we have to all keep working on that and work together and focus on training. Training, I think, is probably one of the most important aspects here.
And that's what we do here in this facility, training. And that's the reason we have Joe, we have Neil, we have a lot of experts here in this building. They are providing on a constant base high voltage training courses. We have currently our 5-day training class. Somebody was asking earlier, is there a Tesla specific class what we do? We do not, but I can encourage you, our 5-day training course, you will learn everything what you need to learn or need to know to stay safe around those vehicles. And at that point, it doesn't matter, is it a Tesla or is it a Ford Mach-E or whatever vehicle. So my team here, Joel and Neil, for example, they will give you the knowledge and skills to really stay safe around those vehicles, and you learn everything what you need to know. So go on the iCar website, sign up for our 5-day training class. This is my thing, my last advertisement step here. We have also Joel talks also about what we did today. It's also part of it to inform you guys about everything what you have to know in the future for dealing with electric vehicles. So we plan always a 30 minutes session. So now we're on 52. Thank you guys for staying tuned in. Thank you for being so interested. And I'm absolutely excited for the big outcome of this event.
Thank you, Chuck. Cenk, thank you, Redline, for coming.
Thank you,
I really enjoyed it.
It's a pleasure to be here.
It was a steep learning curve. Thank you very much.
Really appreciate it.
Thank you.
Thank you.
Thank you, everybody.